On this entry, the STEM journals, Deadly Diseases, Blazing Ballistics, and C.S.I. Arizona, when I focus on forensics.
Author, musician, meteorite hunter, adventurer. I've led an eventful life. Now I'm exploring exciting STEM careers and recording what I find in the STEM journals.
Forensics is the scientific method of gathering and examining evidence. DNA, fingerprints, ballistics, even fire and diseases. These fascinating disciplines create thousands of jobs a year and have spawned almost as many law enforcement TV shows, where everything is solved in just 60 minutes. But what's the real story? And who are the people behind the scenes in forensic science? I'm in the Center for Microbial Genetics and Genomics at NAU, and I'm about to talk deadly diseases with a man who's been branded the Bioterrorism Warrior. Paul, I have to tell you that I meet a lot of people who have interesting careers, but really, microbial forensics?
Yeah, it's pretty exciting, isn't
Yes.
it? You know, microbes are these small things that can cause disease, and unfortunately, sometimes they're used for nefarious acts. You know, people use them to cause crimes. And so microbial forensics is when we go back and investigate these crimes just like they do other types of crimes like murders and robberies.
So there could be a natural outbreak of a disease, but that same disease could be used in an attack. How do you tell the difference?
Well, in 2001, when the anthrax letter attacks occurred, that's exactly what the FBI asked us to do. We went out and we looked at the DNA of the strain of anthrax that was in the letters, and we could tell by looking at the DNA that it was a laboratory strain.
So you personally worked on the famous and terrifying anthrax attack?
I did. You know, the FBI called me up and said, Paul, we need your expertise, and I just about dropped in my tracks. And we responded very quickly, and again, we figured this out. Before the first victim died, we knew that it was a laboratory strain. You know, my job is always filled with trying to differentiate the natural from the unnatural. Natural outbreaks of disease happen all the time. In fact, we had this outbreak of cholera in Haiti, where we were able to figure out that it was a natural outbreak, but we figured out that it came from Asia.
I can tell that you're a very modest gentleman, but I have to say this. You're a crime-fighting, germ-fighting superhero making the world a safer place for us ordinary humans.
Thanks a lot, Geoff. You know, I'm gonna have to take off now. You should go in the laboratory and see where the real action goes while I go off and solve some other crimes and study some other diseases.
Can I ask you just one question?
Yeah.
Why would you want to work in a place that they call the Anthrax Lab?
Why wouldn't you want to work in a place they call the Anthrax Lab?
Why wouldn't you? That's a good answer. Christian, you're clearly a very accomplished and bright fellow. Why are you working in a biohazard lab? Is it scary?
When I started, I was horrified. But honestly, Geoff, I'm more interested in medicine, and I always have been. It's actually shown me the necessity of this work. Being able to track a disease, see how it spreads, see where it comes from.
I like your career path. So you kind of started with the most dangerous, hazardous part of medicine, and then you can take what you've learned and go out and help cure people.
Hopefully, that's the plan.
I love it. Well, please carry on. You're doing a splendid job there. Sally, I told you about this before. You're not doing it right. No, you see that space in the green thing there? No, the other side.
Actually, Geoff, Sally's doing it right. You know what she's doing here? She's sequencing DNA.
And what's the purpose of that?
Well, she's going to get the whole genome sequence of this one isolate, and then she can compare it to our whole collection. See, we keep a database of all the pathogens.
Oh, and this is the resource that you will use in studying outbreaks to see if it's perhaps a pathogen-based crime.
That's right. We need to have many other isolates to compare this one isolate with. But we don't have to just do this with forensics. We can also use these genome sequences to help with public health, because knowing the genome of these pathogens will help us to treat people if they get sick.
Which could be a real lifesaver in the case of an outbreak of a deadly pathogen.
Absolutely. Time matters when someone is sick.
Indeed.
Hey, Geoff, what are you doing in here?
Oh, Paul told me to come in and just knock around the lab a bit.
Do you know what this chamber's used for?
Looking at cool stuff?
It's our dangerous pathogen cabinet.
Oh.
You know, there's a lot of people that want to work in this lab, and it requires a lot of training. I don't think you're on that list of people.
How did you get on that list?
2001, I was looking for a summer job. I started working on a team that studied prairie dogs, and they started dying. We found out they were dying from plague, and I was hooked from then on.
The plague?
Yersinia pestis, yes. But you know what? You got to put that down and get out of there.
Oh, well, I gotta go look at fire investigations anyway. Can I keep this?
No, please get your hands out of there.
I trade the biosafety lab for a chocolate lab. Phoenix Fire and I investigate fire forensics. Coming up on the STEM Journal. STEM Journal Supplemental. The science of forensics is all about evidence. That could be the DNA sequence of a germ, or a body, or, in this case, the inside of a burned building. You'd expect all evidence to be lost when it's subjected to the destructive force of a fire. Well, I'm at the scene of a real fire investigation to follow Captain Fred Andes of the Phoenix Fire Department Fire Investigation Unit and his dog Sadie to see if that's really the case. Fred, I'm super excited to be visiting this site, and I brought my special flashlight, I've got these special gloves, I've got evidence bags, so maybe I could help you collect some stuff.
Yeah, Geoff, maybe you can, or maybe you can keep your hands in your pockets, and let's just see where it goes.
I was afraid you might say that. So how would you begin investigating a site like this?
First thing I'm gonna do is talk to the fire crews and see what they had. I'm gonna take a look at the outside of the building, which I've already done, kind of collect a little bit of data, put some thoughts in my head, and then I'm gonna work my way to the inside. And once we come inside, I'm gonna start with the least burn area and work my way to the most burn area, trying to eliminate things as I go to find out where the fire originated.
With this much damage caused to the building, I'd imagine you lose a lot of evidence. How do you follow the trail of clues to suggest origin and cause?
Well, we actually use a scientific method. We find out what our problem is and we analyze it, and we go around collecting data. One of the big things we notice is that there's no power to this building. So we rule out anything electrical unless we see appliances or electrical cords coming from another building. We eliminate everything else till we find out where it started, and then we try to narrow it down even more if it's possible.
It's real detective work.
It's real detective work, and there is a science to it. It's just that it's a very difficult science, and it's always changing. Fire is a very interesting monster, and it's hard to know what it's going to do. You can see, Geoff, we're starting to get a little bit closer to what would be the point of origin. This room, we have smoke damage on the walls, and if you follow the smoke damage, you'll see that it pretty much leads through that doorway. So as we, again, narrow in on where the evidence takes us, we're going to keep on moving that way.
It's such specialized work, and I understand that you're not just trained as a fire investigator, but you're also a certified peace officer.
Correct. So we give up our helmet and our hoses, and now we have guns and badges, and we do police work. We're like detectives, but just specializing in fire scenes.
Fire detectives?
So fire detectives, that's what you got.
I meet a lot of interesting people in my work, Fred, but I have to tell you that Sadie's the first four-legged detective I've ever worked with.
There's a job for everybody. Sadie has a job, and she picks up accelerants, petroleum hydrocarbons, and our whole world is made up of them. So she somehow is able to figure the difference. Sadie, seek, 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 show me, show me. That a girl.
So she's found something right there. That's her signal to you.
So what I would do is mark that and come back and collect that as evidence, send it off to the lab, see if they can pick up on any gasoline, lighter fluid, diesels, acetone, something that maybe somebody used to start this fire. 30 years ago when I got on the job, I got on to be on a fire truck. I never thought I'd go through the police academy. I never thought I'd do this, and I certainly didn't think I'd have a police dog. It's an interesting job. There's a lot of different things that go, different parts, but for the most part, it's solving a puzzle, and it makes it pretty interesting for us. Now, Geoff, we're starting to get a little bit closer to what looks like at least the room of origin. We just walked through a doorway. It's got charring all the way to the ground here. Oh, yeah. This cabinet here is burned off on the front half, and we got soot all the way around us, which probably means this room reached its flashover temperature. The whole room ignited at once. But the other thing that we have, if you look on this wall, is we have no soot, which we call a clean burn, which probably means the fire was longer and hotter and burned more over there.
So you mean this section here, the fire was so hot that it's burned the soot that it deposited there earlier?
Exactly, and if you look over against that wall, we have what looks to be the remains of a sofa or a chair, and it's burnt much worse than the other wood things in here. So we're getting narrower to what we believe is the point of origin.
Fred, I've watched a lot of these forensic crime dramas on TV, and they always seem to solve these ultra-complex cases in a 60-minute episode, but I've seen you come in here, examine the site, you've worked with C.S.I, and then you'll take your findings back to the lab. How long might you actually spend investigating a site like this?
I could be here for hours or maybe even days, and sometimes the ongoing investigation lasts months. The forensic stuff, I have to collect it the day I'm here. And heat and smoke, they take their toll on fingerprints and DNA, so that's not always a big thing for me. And that'll go off to the lab as well, whatever I collect, and they'll get that back to me in a few weeks. So as far as 30 or 60 minutes, no, that's not happening.
I'm not sure fortunate's the right word to see such devastation, but it is fascinating, and this is the great part about my work, is I learn how things are really done.
It is a science, and it's as soon as you think you know something, you realize you don't know anything. That's the beauty of our job, is to try to figure things out when the unknown is there.
Well, thank you for getting me all fired up about forensics.
No pun intended.
Still ahead on the STEM journals, the cutting edge of ballistics might be point-and-shoot 3D imaging. Becca, I really hope that you and the other young STEM investigators appreciate the hazards I've subjected myself to in order to explore forensics for your benefit. I've been in the biohazard lab, exposing myself to deadly diseases. I've been exploring this blown-up building.
Geoff, I'm here too, and it seems pretty safe.
Well, there's clearly more to investigate, even in Arizona high school classrooms.
Yeah, forensics is definitely popular in high school.
And you've got the right vest for the job, so I want you to collect evidence on that while I head up to Flagstaff to meet with an NAU physicist who's taking aim at how law enforcement look at ballistics. You must be Chris!
Yeah.
Funny thing, when I meet physicists, it's usually in the lab, but I gather you've got something to show me at the shooting range.
Yep, we're going to go and shoot some guns, collect some samples, and then we're going to take them back to the lab and analyse them.
And you're English!
Yes, indeed.
This is going to be tons of fun. Lead on.
Okay.
Chris, I understand that ballistics is about matching a spent cartridge with a particular firearm, but how do you actually do it?
Okay, so the general idea is that we recover a spent shell casing from the crime scene. So when a gun fires, it leaves a particular set of markings and striations on the back of the shell casing that are unique to a particular weapon.
So each gun has its own fingerprints on a cartridge?
That's correct.
Huh.
No two weapons are alike in their markings.
Now, there's a way in which I can really fully understand and appreciate this, and that way would be for you to let me let off some rounds.
Okay, great. I'm going to have a researcher do exactly the same thing. So Geoff, you and Michael are going to be firing our 9mm weapons.
Very good.
Sounds good.
Okay, gentlemen, the range is hot. You may load and make ready, and fire at will. Keep your guns pointed downrange, please. Drop your magazines.
All right, we fired these two 9mm. They look exactly the same to me, but I don't see any so-called unique fingerprint on these shell casings.
So the features we're actually looking for are not something you can see with the naked eye. You need a microscope in order to see them. So law enforcement agencies, they'll typically take a photograph of the back of the shell casing to do the matching. In our research, we are developing an optical system which enables us to see the markings and the striations in 3 dimensions, so we actually have the depth of those markings.
3D, like an avatar?
Yes.
Do we get special glasses?
No.
Well, you know what the kids are saying, pick or it didn't happen. I want to see visual proof of this.
Okay, we can go to the research lab to see this.
Excellent.
This is the optical metrology lab, and we conduct optics research in a wide range of areas, from biomedical science, materials characterization, and of course the ballistics forensics. And of course, Glenn actually has a sample up on the computer right now.
So this is one of the cartridges that we fired at the range today, and I can immediately tell that that was one of mine, and that was one of my really good shots where I hit the target.
I don't know if it's your best shot, but it's definitely one of the cartridge cases that we shot at the range today. And if you look over here, this is the 2D image. You can see the firing pin impression and one of the breech mark impressions. From this image, we're able to create a 3D reconstruction using this optical interferometer over here. So out of here is the LED, which shines light into the beam splitter. The beam splitter splits the beams. One beam hits the cartridge casing and comes back. The other beam hits the reference mirror and comes back. These two beams interfere and then go to the CCD camera, and that's what we see here.
That's a live picture that we're seeing.
Yeah, this is a live picture right here.
So if I do this, I'm interfering with the interferometer.
Yes, you are.
I could not resist that.
So you're able to see the interference pattern here, and using that interference pattern, you construct a 3D profile, which would look something like this.
Wow! Well, this is clearly light years ahead of the old way of doing things. What are the practical applications? How would you like to see this used in the future?
In the future, we would like to compress this down to a smaller size, so it would be field portable, and you can actually take it to a crime scene. There won't be any possibility of evidence contamination.
It's one thing to look at a black and white photo that's flat, but now you can see the actual shape of the pin.
Yeah, you can see the shape of the pin, and you actually have a scale over here in micrometers, so you can actually see the depth of the pin, and that gives you much more information to determine what firearm this cartridge casing came from. This here is a Glock, and the breech is individual between each firearm.
Oh, but I was firing the Smith & Wesson, so that actually isn't one of mine. So I'm innocent.
I guess you are.
What a relief. I'm off the hook, but our young STEM investigator collects evidence with the North Valley Explorers. Up next on the STEM Journal.
It looks like Geoff had some fun shooting guns and also learning about 3D ballistics. He did really interesting journal entries on microbial forensics and fire, but my journal entry is going to be more interesting. You don't see a lot of kids in high school who are already getting a head start on careers in STEM fields like forensics, but that's exactly what's happening with the North Valley Explorers.
Everyone's briefed and everyone's cleaned up and has their gear in check. All right, teams, go ahead to your scenes.
Let's start from here and go there.
Take that flashlight and you literally check everything that you could look under, over, around.
So I can see students working here on 4 different crime scenes. What is this program all about?
Well, you know, the students that actually don't like science, they typically love this science course because everything's hands-on. You're seeing some of our students placing evidence markers as well as taking photographs. She's also using various skills learned in English, social studies, but really taking the fun parts of the other types of subjects and really bringing them together.
In my anatomy class, we're dissecting cats, which isn't very relevant to the human body, but I could see here that with a crime scene, it's the real deal. Like your students are learning exactly what they need for the future, for a career, right?
Yep, in our class, we actually do over 90% hands-on with about 10% notes. We actually take it to where it's like, here's what it looks like in real life. Instead of having to do notes and show them, they get to do it. So they may take a little bit of notes, but they'll do a whole lot of hands-on.
You gotta have the temperature of that room with that little temperature gun and the body.
So forensics is constantly changing in technology and techniques. How do you stay current with that?
Well, first and foremost, to be a good educator in this field and to teach these kids what they need to do, we have to be professionally developing constantly. We have to read and we have to go to seminars and we have to know what the new techniques are. Some classes, you would continue the same curriculum each year in the same manner. In this field, it can change actually in a day. We have to know it before we can teach it.
This teaches skills beyond forensics. It's everyday life skills.
Absolutely. In fact, that's probably the first objective in teaching, is to get them to understand that we're not teaching you to be a police officer or to go into forensics. We're teaching you how to follow through and think for yourself. We want them to ask us not what's the answer, but how can we find the answer? And this is a perfect setting for the kids to do math and science and English and everything.
We have 5 foot 8 inches.
So Jessica, you've had 4 years of experience with this program and now you're studying forensic science in college.
Yes, I've been with the program for 4 years, all of high school, and I found Grand Canyon University, which has an amazing forensic program that I really wanted to look into, and I found an even bigger passion.
So you've investigated a lot of crime scenes like this, and I watched some of those crime shows on TV. How realistic is it they can solve a crime in 30 to 60 minutes?
It's not very realistic. Most of their evidence is placed out, so it's easy to find. and they have everything scripted. But a real crime scene can last anywhere from 2 to 12 hours. And I've done a couple competitions where we are timed between 30 and 40 minutes at the most.
So you have these competitions. Do you compete against different schools?
We do. We can have anywhere between 15 and 20 different schools competing at once. It's a competition that can last between 1 to 2 days, and we do a crime scene and a lab, identifying evidence and eventually finding our killer.
That definitely seems very interesting. I'm gonna have to learn more about forensics.
If you're interested in forensics, you should know that it all starts in the classroom. Be sure to focus on math, biology, chemistry and physics, even psychology and criminology. Join a science club at your school. Ask your teacher to point you in the right direction for some great forensics activities. And be sure to check out the books and television and movies that are available. Stay focused, stay curious.
On the next entry, the STEM journals, streets and highways are obvious markers establishing a civilization, but there's a lot more to learn about the infrastructure of our cities and towns as designed by civil engineers. That's next week on the STEM journals.